Good morning, children. We proceed on to exercise 9.5 problems based on continuity. Let us recall. To show a function is continuous, check left limit, right limit and function value are equal. Exercise 9.5 question number 5. Show that the function x cube minus 1 by x minus 1 if x is not equal to 1 and 3 if x is equal to 1 is continuous on minus infinity infinity. Call the function as f of x. Let us simplify by factorizing the numerator, which is of the pattern a cube minus b cube. The formula is a minus b into a square plus ab plus b square. Here a is x and b is 1. We can very well write 1 as 1 cube. As I substitute, it is x minus 1 into x square plus x plus 1. As we cancel the factor x minus 1, we get x square plus x plus 1. The left limit, I need to check at 1 because the problem is at 1 only. Not equal to 1, it is defined in one way. Equal to 1, it is defined in some other way. When I want left limit for 1, limit x tends to 1 minus the remaining factor, that is x square plus x plus 1. As we substitute 1, it is 1 square plus 1 and my answer is 3. The right limit, we need to find limit x tends to 1 plus of x square plus x plus 1. As I substitute 1, it is again 1 square plus 1 which is 3. The function value when x is equal to 1 is 3. So I write f of 3 is 3. As we check left limit, right limit and function value all are equal. Therefore, we can conclude f of x is continuous at x is equal to 1 and hence it is continuous on the entire real number set, that is minus infinity to plus infinity. Question number 6. For what value of alpha is this function f of x equals x power 4 minus 1 if x is not equal to 1 and alpha if x is equal to 1 continuous at x is equal to 1? What is the difference between these two problems? Here we check whether left limit, right limit and function value are equal and so we declared continuity. But in this problem, they have given continuity. We need to find alpha. So what do I understand? If f is continuous, the left limit, right limit and function value should be equal. Alpha is the function value at x is equal to 1. So to find alpha, it is enough if I find the left limit or right limit. As I look at the function which is x power 4 minus 1 divided by x minus 1, rewriting it as difference of squares. X power 4 is x square the whole square. 1 can be written as 1 square. Again we use the format, it is a plus b into a minus b. X square minus 1 can still be factorized as x plus 1 into x minus 1. Cancelling the like factor x minus 1, we get x square plus 1 into x plus 1. As I substitute left limit, limit x tends to 1 minus x square plus 1 into x plus 1. As we put 1, we get 1 square plus 1 into 1 plus 1. That is 2 into 2 which is 4. So the left limit answer we arrive at 4. Checking the right limit. Again we put 1 plus. So wherever x comes, if I put 1, it is 1 square plus 1 into 1 plus 1 which is 2 into 2 and that also reduces to 4. Because the function is continuous at x is equal to 1, we can declare the left limit, the right limit and function value are equal. The left and right limit lead to 4. Function value is also 4. What is function value according to the statement? At x is equal to 1, the function value is alpha. So function value we have written alpha and the left and right limit lead to 4. So we get alpha value is 4. Question number 11, we want to check whether there is a removable discontinuity. What do you mean by removable discontinuity? Left and right limit exist and they are equal, but function is not defined at x0. Here the question is, if the discontinuity is removable, we need to define a function g that agrees with f for x not equal to x0 and is continuous on R. As we call f of x, the question here is to check at -2. Let me simplify. F of x can be factorized x square minus 2x minus 8 by x plus 2. Minus 8, as I factorize, it is 4 into minus 2 minus 4 plus 2. Minus 4 plus 2 gives me minus 2, minus into plus minus 4 into 2, 8. So the numerator, I can rewrite x minus 4 into x plus 2. The denominator is x plus 2. As we cancel the like term, f of x equals x minus 4. My question is to check the left and right limit. So, as I find out the left limit, x naught equal to -2. So, f of -2 minus, that is limit x tends to -2, the function is x minus 4. And my answer is -2 minus 4 or it is -6. Let me check the right limit. What is the right limit? X naught equals -2. We write -2 plus, that is limit x tends to -2. Given it is x minus 4 only. As I substitute, my value is -2 minus 4, that is -6. So we can declare left limit is equal to right limit. And function value we should restate as this limit value. So how are we restating? G of x equals the given function x square minus 2x minus 8 by x plus 2 whenever x is not equal to -2. Why do I say not equal to -2? If I put -2, -2 plus 2 will become 0. Denominator becomes 0. The function is not defined. So whenever x is not equal to -2, I assume the given function, and when x is equal to -2, because it needs to be continuous, we have to assume the limit value. The left and right limit gives us -6. Assume the limit value when x is equal to -2, and we will say g of x is continuous on R. So we have redefined f of x as g of x. This part we write as it is, but ensure the denominator is not 0. X plus 2, 0 means x is equal to -2. So only at that point assume the limit value. So such thing we call removable discontinuity. So here x is equal to -2 is a removable discontinuity. And we have redefined g of x, that which agrees with f. Proceeding on to the second part, it is x cube plus 64 divided by x plus 4 and given x naught equal to -4. So as I consider the given question as f of x, Let us factorize the numerator. We recall this formula a cube plus b cube. A plus b, a square minus ab plus b square. As we substitute, here a value is x and b value 64 can be written as 4 cube. So it will be x plus 4 into x square minus 4x plus 4 square is 16. Denominator x plus 4. As we cancel the like term, I get f of x is x square minus 4x plus 16. To find the left limit, my question is at minus 4. That is f of minus 4 minus. Limit x tends to minus 4. The value is x square minus 4x plus 16. As we put minus 4 square minus 4 into minus 4 plus 16. It is 16 plus 16 plus 16, that is 48. The right limit, when x naught is minus 4, we write minus 4 plus f of minus 4 plus. Limit x tends to minus 4, substitute in the same function. X square minus 4x plus 16. As I put minus 4, it is minus 4 the whole square, minus 4 into minus 4 plus 16. 16 plus 16 plus 16, which is 48. So we declare left limit and right limit are equal to 48. Now let us redefine the function. G of x, the given question, x cube plus 64 by x plus 4. The denominator should not become 0. If I put x plus 4 0, I get x is equal to minus 4. So when I redefine, x is not equal to minus 4. When x is equal to minus 4, given the function is continuous on R, so g of x can be continuous if the function value and limit value are equal. So what is the limit value we get? 48. This answer I define for g of x when x is equal to minus 4, and we can declare g of x is continuous on R and x is equal to minus 4 is a removable discontinuity. Third subdivision, f of x is 3 minus root x by 9 minus x. As we simplify the problem, the denominator 9 can be written as 3 square, x can be written as root x the whole square. And we know the denominator is a square minus b square. So it is a plus b into a minus b. Cancelling this 3 minus root x, we get f of x equals 1 by 3 plus root x. Now, let us find out the left limit and right limit. What is left limit? We need to put at x naught equal to 9. So we say f of 9 minus, that is limit x tends to 9, 1 by 3 plus root of x. As I substitute 1 by 3 plus root of 9, we get root 9 is 3. So 1 by 3 plus 3, that is 1 by 6. So we get left limit equal to 1 by 6. Now we need to find right limit. At x naught equal to 9, f of 9 plus limit x tends to 9, again we write the function 1 by 3 plus root of x. As I substitute 9, 3 plus root of 9, we get 1 by 3 plus 3, that is 1 by 6. As we check, we get left limit is equal to right limit. So we can redefine the function. Let g of x is equal to, The given thing we write as it is 3 minus root x by 9 minus x, but x not equal to 9. Why? If I put the denominator 0, I get x is equal to 9. Denominator should not become 0. So we shall write x not equal to 9. When x is equal to 9, let us declare the limit value. What is the limit value? The left and right limits lead to 1 by 6. As I substitute 1 by 6 as g of x value when x is equal to 9, it becomes a removable discontinuity. And I can declare g of x is continuous on the entire real number set. And we will say x not equal to 9 is a removable discontinuity. And hence we have proved the problems. Exercise 9.5, question number 12. Find the constant b that makes g continuous on minus infinity, infinity. Given g of x, whenever we declare g is a continuous function, the problematic number is 4. So we need to check the left limit, the right limit. Obviously, continuity implies left limit and right limit are equal and limit should exist for continuity to be there. Because it is mentioned continuous, let us declare left limit is equal to right limit. When I am at left limit for 4, I should substitute here 4 square minus b square. When I need the right limit for 4, I am here, so substitute here. Wherever x comes, I can very well put 4. It is 4 into b plus 20. As we equate left limit and right limit, bring terms to the right. It is 4b plus 20. 4 square 16 goes to the right as minus 16. Minus b square goes as plus b square, which is equal to 0. As we try to simplify this, it is b square plus 4b plus 4 equal to 0. Factorizing for b, I get 2 2's are. So my answer, b plus 2 the whole square is 0, or b plus 2 0, which gives us b equal to minus 2. As we look at the question, my question is to find the constant b, and we have derived the constant b as minus 2. Question number 13. Consider the function f of x equals x into sine pi by x. What value must we give f of 0 in order to make the function continuous everywhere? As I have sin x, let me recall, sin x lies between minus 1 and plus 1. But I want sin pi by x. Obviously, that is also sine value. So, sine will always lie between minus 1 and plus 1. When I multiply by x, as I need it in the question, every term in the inequality, let us multiply by x. So, as we multiply by x, this is minus 1 into x, this is 1 into x, and this is x into sine pi by x. As we know, whenever I have inequality, they represent 3 different curves. This curve, x into sine pi by x, is in between minus x and plus x. So, I can very well apply sandwich theorem. My question is f of 0. That is, I need to find out limit x tends to 0. So, taking limit x tends to 0 for all the 3. When x tends to 0, minus x becomes 0. Plus x also becomes 0. When these two limits tend to 0, the middle function also tends to 0 using sandwich theorem. So, coming back to the main part of the question. My question is f of x equals x sine pi by x. They want us to find f of 0. The given word is continuous. Whenever I say f of x is continuous at some particular point, f of 0 tells me at x is equal to 0. If limit x tends to 0, f of x should be equal to f of 0. My question is to find f of 0, but f of 0 is nothing but limit x tends to 0 f of x. To find this, let us write down limit x tends to 0 x into sine pi by x. Finding this limit is a difficult task, so we compare. The trigonometrical value of sin x is between -1 and +1, and we have derived the limit value as 0. So when I substitute the limit value 0, I immediately imply f of 0 is also 0. Because f is continuous, the limit value and function value are equal, and hence the problem is done. Question number 14. The function f of x is x square minus 1 by x cube minus 1 is not defined at x is equal to 1. What value must we give f of 1 in order to make f of x continuous at x is equal to 1? So in all these problems, we would like to declare only one statement, that f of x is continuous at a particular point if the limit value and function value are equal. Limit x tends to 1, f of x equals to f of 1. So my question is to find f of 1. So to find it, let us find out limit x tends to 1 f of x. As the given function is rational, let us try to factorize and cancel the like term. The numerator x square minus 1 can be treated as x square minus 1 square. So it is a square minus b square pattern, which can be written as a plus b into a minus b. The denominator is x cube minus 1. 1 can be written as 1 cube. So we have x cube minus 1 cube, which is of the pattern a cube minus b cube. And the formula is a minus b into a square plus ab plus b square. As I substitute a as x and b as 1, we get these two factors. Cancel the like term x minus 1, we arrive at limit x tends to 1, x plus 1 by x square plus x plus 1. Substitute 1, I get 1 plus 1. Denominator 1 square plus 1 plus 1. 1 plus 1 gives rise to 2, and denominator 1 plus 1 plus 1 is 3. So the limit value is 2 by 3. That tells us the function value is also 2 by 3 because f is continuous.